Hi class, this is Ms. Golnik here. I wanted to go over with you a way to find a pattern rule for decreasing linear sequence. So I have in front of me a pattern that's decreasing. It goes down 9, 4, negative 1, negative 6, negative 11. So we want to identify what they're going down by each time. And as we can see, 9 take away 4, it's 5. So it's going to be going down by 5 each time. I'm going to do that 3 times just to make sure it's linear. And we want to also, I'm going to put a line here so we can label which number each of these values are in this sequence. So 9 is in the first position, 2 is in the second, 4 is in the second position, negative 1 is in the third position. So you can just go ahead and do that. And we're going to call this the term number. So when the term is 1, n would be 1. So, and this would be like the result that you would get. And then we're going to also notice that because it's going down by 5s each time, that means that essentially we're counting by 5s. So in the first value, we're going to put 5. We're going to count by 5s here. 10, 15, 20, 25. So these are our 5s times table. But here's where we have to do something else because it is a decreasing linear sequence. So we're going to put negatives in front of these. It's going down by that each time. So our formula for finding an expression for linear sequence is an plus b. So a is what we call the constant, and in this case it's constantly going down by negative 5. So this is our constant. It's negative 5. Okay, so we have part of our expression done now. So that means we can write negative 5 in there for a, and this is what we're left with. Negative 5n plus b. So now what we need to do is figure out what is b. Okay, b is going to be solved by adding 5 back to 9. So in this case, like we're going down by 5s each time. So instead of subtracting 9 from 5, we're going to do the opposite. We're going to add 5 back to 9. So 5 plus 9. Okay, and that will be our b. So we're going to take 9 plus 5, and we get 14, and that's going to be our b. So our b equals plus 14. So now all we're going to do is rewrite our expression with what we have. That's negative 5n plus 14. Now we need this to solve anything up here. So we want to check to make sure it works though. So what we're going to do is we're going to be trying to get our 9 by using the expression we came up with. So that means negative 5n when n equals 1. So when n equals that first term, or term number 1 in the pattern, we're going to put the 1 in for n, and then we're going to add 14. So then you have negative 5 plus 14 equals 9. And if you're struggling to know like how that is on the number line, if you're at -5 and you add 14, you're going to get to 9. So now when we want to find a different number in the sequence, let's say we want to find the 10th term in the sequence, we can do that because we have our 5n plus 14. So when the term number is 10, we're just going to put that 10 in for n and put our 14. So we have our -50 plus 14. So we're going on the number line 14 times this way, but we're not passing 0, so we're going to end up with a negative number. But we're still just going to go 50 minus 14. I'm going to borrow and subtract 10 from 4, 4 from 1, and get our -36. It's still negative because we haven't passed 0. So we can use this to find any number in the sequence. Another thing I wanted to point out is that if you're a little bit confused of this horizontal version of this table, I'm going to put a square around this. This is actually related to an in and out table like this. So if x and y, this is our in, this is our out. This x is our Tn, and the y is our result. So just turning it over on the side, we have the first number in the sequence, the second, the third, and the fourth, and that would be 9, 4, -1, -6. So this is just that turned on the side. So you can also do it this way if that makes it easier for you.